Hello! Welcome to today's lesson on distance-time graphs. In this lesson, we'll understand the essential features of distance-time graphs, such as their gradient and axes. We'll also explain how to interpret these features. Then we'll outline the distance-time graphs associated with specific cases. Up to this point, you've learned how to calculate speed using its formula and how to compute average speed. This foundation allows us to explore how distance-time graphs give us a visual representation of an object's motion over time. Understanding these graphs enriches our broader knowledge of physics by providing tools to analyze and interpret motion in a clear and insightful way. Let's get started. A distance-time graph plots an object's distance against time. The horizontal axis, which is also known as the x-axis, represents time, usually in seconds, while the vertical axis, which is also known as the y-axis, represents distance, usually in meters. This type of graph provides a visual representation of how an object's position changes over time. The gradient of the graph, which is the change in distance divided by the change in time, gives us the speed of the object. The steeper the gradient, the higher the speed. Let's use some examples to illustrate concepts. Imagine a car travels at a constant speed of 30 meters per second. On the distance-time graph, this will appear as a straight line rising steadily from the origin, 0, 0. After 1 second, the distance will be 30 meters, after 2 seconds it will be 60 meters, and so on. If another vehicle travels at 60 meters per second, its line on the graph will rise twice as steeply compared to the first car. Conversely, a third vehicle traveling at 15 meters per second will have a line with half the steepness of the first car's line. Now let's look at an example of a stationary object. A parked car will show a flat horizontal line on the graph, staying at the same distance over time. Finally, let's look at an example of changing speed. Consider a cyclist accelerating. Initially, the graph might start as a gentle slope and become steeper over time, indicating that the cyclist's speed is increasing. If the cyclist then slows down, the slope of the graph will start to level off, indicating a reduced rate of increase in distance. Good work today. In today's lesson, we delved into the main features of distance-time graphs. We learned that the horizontal axis represents time and the vertical axis represents distance. By examining the gradient of these graphs, we can determine an object's speed. We covered various scenarios: constant speed, indicated by a straight, upward-sloping line; higher speed, shown by a steeper slope; lower speed, depicted by a gentler slope; and a stationary object, represented by a flat horizontal line. We also looked at changing speeds, which appear as curved lines on the graph, with upward curves indicating speed-ups and downward curves indicating slowdowns. Understanding distance-time graphs equips us with a valuable tool for visualizing and interpreting motion, allowing us to grasp the dynamics of how objects change position over time. Watch the rest of the GCSE physics course at Sophos Education.